let's talk about special relativity and meaning. And there's a standard way in which philosophers present this kind of approach to understanding what Einstein did. Because if you read Einstein's famous 1905 paper called On the Electrodynamics of Moving Bodies, you will see something really striking. You will see that Einstein begins by asking a question about meaning. Now, I just said, if you read this paper by Einstein, and some of you must have rolled your eyes, but it's really kind of interesting. Look it up on the web, download it, and have a look at the first paragraph or two. The first paragraph, maybe you might not quite follow what he's on about, because he's talking about conductors moving relative to magnets, and if you're not a physics person, it might not say that much to you. But pretty quickly after that, Einstein asks a very simple question. He says, look, when we're trying to define motion, mathematically what we do is simply try to state where a given object is at a given distance at a given time. Okay, so if I'm trying to describe motion just very simply, if you're driving from St. Louis to San Francisco, I might just simply want to state, where are you at any given point in your journey? At what time did you arrive in King City? At what time did you arrive in Salinas? At what time did you arrive wherever? Okay? So Einstein asked this question that seems almost childlike, which is, what does it mean to say that an object is at a given location in space at a given time? And he says, well, look, when it comes to what it means to say that the object's at a given location at a moment in time, we know how to make sense of that. We know what that means because I can specify the location of an object, for example, inside a lab, by simply telling you how many meter sticks you have to lay end to end from the corner traveling in one direction, then a direction that's at right angles to it, and then a direction that's at right angles to it. So that you go all along the X, Y, and Z, right? So that if I'm in the lab, right, and I'm trying to locate this object, I tell you, well, you start here at the origin, you go way out here, you come out here, and then you go up to the top, and you miss because my sketch is so bad. But anyway, you get to the object, right? And I lay meter sticks from the origin along this dimension, then along this dimension, and then along this dimension. And Einstein says, yep, that's what we mean by saying that this object has location XYZ. Okay? But what about if I want to assign a time, right, to this object? So suppose this object is a flashing LED, and I want to say the flashing LED flashed at a certain time. Well, if I'm right next to the object, there's no problem there at all because I just put a clock right beside it, right? And I look at my clock and I see what time the light blinked, and I just say, oh, it blinked at 12:35 in the afternoon on whatever. But what if that blinking light is like on the surface of Mars? Things start to get really interesting then. How do we assign a time to an event that is occurring very, very far away from us? Especially given a crucial postulate of special relativity, that is, that light travels at a constant speed for all inertial observers. Well, it's going to take some time for the light from Mars, if this thing is on the surface of Mars, right, and it emits a little flash of light, it's going to take some time before it gets to Earth. And I'm trying to assign a time to it, but I only get the beam of light when I get the beam of light. So how do I figure out how to assign a time to what Einstein called a distant event? And in answering this question, Einstein came up with a very, very famous thing, which is called Einstein's definition of simultaneity. And if we were in my philosophy of physics course, the philosophy of space, time, and matter course, we could go through all the details of the definition of simultaneity, and exactly how you do it, how you decide the two events are simultaneous, even if one's happening here and the other one's happening on the surface of the moon or Mars or Alpha Centauri or some distant region of the universe. But we're not going to do that for this class. Instead, all I want to emphasize for today's class or lecture is that the key thing that Einstein did that really impressed philosophers was that he said, in order to answer a question about the meaning of a concept, you have to specify how you verify that concept. Okay? So to specify the meaning, and now I'm going to say it a little bit differently to make it more precise in the way that philosophers who are sympathetic to logical positivism would say, right? So to specify the meaning of a term, okay, so some bit of language in your scientific theory. To specify the meaning of a term, you need to specify the empirical conditions for verifying it. And that, of course, is what became verificationism. Right? That we can say these two events are simultaneous if and only if this physical thing happens that I measure in the lab. And so simultaneous doesn't mean some spooky metaphysical stuff. It just means that this particular empirical procedure yielded a specific measurement outcome. That was a very powerful thing. And there's a famous quotation by the logical positivist named Moritz Schlick, who Einstein had a lot of respect for, where he says, basically, this is what we learned from Einstein. Einstein taught us that the only meaningful terms in science have to have their meaning expressed or stipulated or defined by empirical procedures that yield specific outcomes. And if you cannot connect a term to empirical procedures for specific outcomes, then that term is literally meaningless. It does not have a meaning. Okay? And that's where this whole thing about the verificationist criterion of meaning that you read about in Suppi and Rosenberg sort of came from. And it really emphasizes this idea that what we want to do with science is make sure that we're not getting tricked into thinking that something is science and meaningful when in fact it's just meaningless talk that's masquerading as science. And again, you might think, well, we don't really have to worry about that very much nowadays. Or maybe you might think otherwise, right? So for instance, if you think about some of the not so distant debates that used to be very lively in the late 19th century, but have somehow resurfaced in the late 20th century and beyond about race science, right? It's actually quite a tricky and subtle thing to try to decide for this purported scientific theory, are these concepts really meaningful? Okay? And here, when I ask, is this term meaningful? What I'm asking is, what is the meaning of this term? And, again, in physics, you might feel like maybe there's not that much debate about that. There actually is. But certainly in other disciplines, especially disciplines in science when they are at an early stage of their development, it can be extremely controversial, even within the scientific community, to ask, for instance, what does the term IQ mean? I mean, I know the words are supposed to be intelligence quotient, right? But what on earth is an intelligence quotient. What is the meaning of intelligence quotient? Well, if you're a logical positivist, what you say is, tell me what you are measuring. Tell me the procedures you're using for measuring what you're calling intelligence quotient, and that just is what the intelligence quotient is. It isn't anything else. It isn't some abstract measure of how smart you are or anything else. Maybe at most it is a measure of how well you performed on some very specific tests. So think about this as you begin your philosophical reflections on science, and even in our contemporary culture, as you go out and read science news or see science news-like things crossing your whatever feeds, I guess people say. Think about, what do we mean when we use all these sciencey words? And do these sciencey words always have a meaning? And if so, how do they get their meaning? The logical positivists thought they had an answer to that. And it was an interesting one, though, of course, as we'll see later on, it faced a number of serious challenges. All right, I hope you have a really great day today.